So in this question, we are asked which of the following processes is both exothermic and spontaneous. It's important to remember that when a reaction or a process is exothermic, one way of knowing that is if its change in enthalpy is negative, if it's less than zero. And what we mean by spontaneous is when it's naturally occurring, or you don't have to cause it, you don't have to force it to occur. Okay, so that's what we're looking for when we look at these potential processes here. So first of all, the sublimation of CO2 at 30 degrees. Now you need to remember what sublimation is. Sublimation is when we go from a solid directly to a gas. You don't go through the liquid phase. But either way, that's going to require some energy. You have to put energy into the system in order to cause that. So that means it's an endothermic process. The delta H is greater than zero, so I can eliminate that as a possibility. Now the next one here, dissolving ammonium chloride in water and the solution temperature drops. I forgot to put that on the handout, pardon that. So that's the key thing. It tells us that the solution of the temperature, it goes down. In this case, it's important to identify your system and your surroundings to get the sign on the enthalpy change. So we're going to say that the dissolving of the ammonium chloride, that's our system. We're going to define that as our system. And then the temperature of the water, that's going to be like our surroundings. Okay? So if the temperature of the water is dropping, that means energy is flowing from the surroundings into the system. Okay? So that is another situation where the delta H is going to be greater than zero. It's going to be an endothermic process. So once again, I can eliminate that. Okay, for the next one, condensation of water at 99.5 degrees Celsius. Well, condensation, that's where we go from a gas to a liquid. And in order for that to happen, the gas has to release energy into the surroundings so that it can condense into a liquid. So this is one where we do have a negative delta H. So the delta H is less than zero. Okay, it is exothermic because that gas has to release energy into the surroundings in order to form a liquid. And so one of the criteria we met. What about the other criteria about spontaneity? Well, does water in the gaseous phase spontaneously become a liquid at this temperature, 99.5 degrees? Well, remember that the boiling point of water is 100 degrees Celsius. So we are lower than the boiling point. So does water vapor spontaneously become water in the liquid phase when it's below its boiling point? So that is yes. So this is also a spontaneous process. So this looks like our answer, but let's go ahead and analyze the other two quickly. So what about this one? H2O in the liquid phase becoming H2O in the gaseous phase at 101.0 degrees Celsius. So once again, this is an example of a spontaneous process because we know that if you're above the boiling point, yes, liquid water will become gaseous water. So we met this by spontaneous criteria, but we also know that in order to do that, to go from the liquid phase to the gaseous phase, that is an endothermic process, not an exothermic process. So this has a delta H that is positive. It's greater than zero. So I can eliminate that one. And what about this one? Freezing of water at 3 degrees. So we know that for freezing, we're going from a liquid to a solid. And in order for liquid particles, molecules, atoms, whatever, to become solid, they have to release energy into the surroundings. So this is one where the enthalpy change is negative. It is an exothermic process. But the question is, does that happen for water at 3 degrees? Well, no, because the freezing point of water is 0 degrees Celsius. So we're not at the freezing point or below the freezing point. So it is not spontaneous. Okay, so the only one that meets both the criteria is C, and that will be your answer.